Hey guys, page 6 was just a lot of more. There was just a lot more of page 5, so I'm skipping page 6. If you know how to do page 5, you should be able to do page 6 without a problem. I'm gonna do page 7 because they teach you a neat little trick here. Um, in the directions, they tell you solve for x in these equations by canceling where possible and transposing terms. Whenever you have the same thing on both sides of the equal sign, you can just cancel that out. For example, right here you've got 15 and negative 15 and negative 15. The signs have to be the same, and the number or variable has to be the same for it to be canceled out. So here we just cancel out the 15. And what we have left is x equals 35, and that's your answer. Here we've got a negative 11 and a positive 11, so you can't cancel out there. You've got to transpose. Transpose is just a fancy word for saying, you know, add 11 to get rid of the 11 on this side and add 11 to the other side to keep it equal. So we have the equation x minus 11 equals 11 plus 22. So x minus 11, we're going to plus 11 here. That's going to get rid of our 11. It's going to allow x to be isolated on one side. But we're going to add 11 to this side too, because of what we do to one side, we have to do to the other. So that gives us x equals 11 plus 22, which equals 23. And then 11 plus 33. 11 plus 22 equals 33. And then 33 plus 11 equals 44. So x equals 44. Easy, huh? Hope it is. I hope it should be easy for you. Here we've got a positive 6 and a positive 6 on both sides of the equal sign. We know this is positive because there's no sign in front of it. So we've just canceled out the 6's, and what we have left is x equals 20 minus 6, and 20 minus 6 is 14. So x equals 14. Okay? Next page. Again, I guess you could do all those by yourself. I'm going to do number 6 because it's a fraction. You guys don't like fractions, I know. X plus 3 over 5 minus 1 over 10 equals 4 3/5 minus 1 over 10. Alright, so what I'm going to do here before I can solve this equation is I'm going to turn this, I don't know, there's different things we could do. So what I'm going to do is I'm just going to move I'm going to get rid of these two. Yeah, I'm going to get rid of these two because they're the same, right? A negative 1 over 10, negative 1 over 10, I can get rid of them because they're the same. And then what I have left is a positive 3 over 5. Since it's a positive, I'm going to use the inverse operation, a negative 3 over 5, to get rid of it. Boom. I'm going to take negative 3 over 5 here. Well, 3 over 5, negative 3 over 5 equals 0. So what I have is x equals 4. Alright, I'm going to do that again because I kind of think I confused you, huh? Alright. Okay, well, we have the same thing. I have a negative 110 here and a negative 110 here. So I just cancel those out. Okay, what I have left is a 4 and 3 over 5 and a positive 3 over 5. Well, I want x by itself, so to get rid of this 3 over 5, I'm going to subtract 3 over 5. That gets rid of that. But what I do to one side, I have to do to the other side. So this side is I'm going to subtract 3 over 5 from this side. Well, I've got 4 and 3/5. Well, if I take 3/5 away from the 4 and 3/5, the 3/5 leave, they're gone, they get subtracted, and all I have left is 4. And on this side, all I have left is x. So x equals 4. Down here, all you got to do is verify our solution. So whatever you got for each number on the top, whatever you got for x, you're going to plug it into the equation to make sure that it is correct. Example here, we've got, in the first one we did, our answer was at x equal 35, so we're going to have 35 minus 15 equals 35 minus 15. 35 minus 15 equals 20, so 20 does equal 20. So my answer is correct, I'm going to have the same number on both sides of the equal sign. If you don't have the same number on both sides of the equal sign, your answer is not correct, and you've got to do it again to make sure that you have the right answer.